Okay, so now we're going to put the first two sections together, okay? So we've looked at inequalities, we've looked at absolute value equations. Now we're going to look at the absolute value inequalities, okay? So the solution set of an absolute value inequality, such as the absolute value of x is less than 2, and contains all numbers whose distance from 0 is less than 2 units as shown below. Okay, so what that means, okay? Remember, absolute value means a distance, right? So if my distance from 2, that means we can go left or we can go right, right? So this says the distance is less than 2, okay? Well, the distance is less than 2, right? So the distance here is 1 unit away, right? So 1 is less than 2, okay? 0 is obviously less than 2, right? Anything in between, 1/2 is going to be less than 2, right? Because so all of these would work, this whole entire section, as well as this section, because everything over here is less than 2. So anything inside of those is going to have a distance that is less than 2, okay? So and that means whenever I'm writing these, I'm still going to have two answers, just like we did for absolute value equations, right? Because I can go left for a distance of 2 and right for a distance of 2. Okay, so there's still going to be two different answers. Now the difference is, of course, that we don't have it equal to a specific number, so you're not going to have a single answer. We're going to have a set of answers, right? So that's kind of what we're looking at. So whenever the absolute value is less than or equal, okay, those are considered and statements. Okay, those are going to be your and statements. So the intersections, we talked about those in the inequality section, the very first one, 9.1. Okay, so those are going to be your and statements. And whenever the absolute value is greater than or equal to, okay, we use the or statement. So those are your unions, right? So this is, if you need to write that down, these are the intersections. Okay, if you're not sure what that means, go back and look at 9.1, right? That's where we learn this stuff. So intersections for and unions for the or statements. Okay, so to help us remember that, we have LAMO, right? I love this one, LAMO. Okay, LAMO, less than is and, more than, I know we usually say greater than, but that doesn't fit, right? That'd be LATO. That's not as much fun. LAMO. Less than is and, more than is or. Okay? Less than is and, more than is or. So that rhymes. That's why we use more than instead of greater than, because more works. It just makes it better. LAMO, right? So LAMO. Less than is and, more than is or. So that kind of helps us remember that anything that's less than, okay, that includes the equal or not equal, but less than is going to be and statements, and greater than statements are going to be or statements. Okay, so for instance here, the absolute value of x is less than or equal to 3. Okay, so just like on this top one, when you're talking about distance, okay, that means that x could be less than 2, right? Because anything from 0 to 2 was going to work, right? So x could be less than 2. Less than is and x could be greater than negative 2. Notice how this thing flips, because we're going to go bigger than negative 2. So that would give me bigger than negative 2 and less than 2. So if it's an and, we're looking for where they intersect, which would be right here from negative 2 to 2. Okay, so let me show you that with this one, and it might make a little more sense than that did. So x is less than or equal to 3. Okay, first of all, less than, that's an and statement. So just start off there. All right, this is going to be an and statement. So we've got x is less than or equal to 3. And, okay, just like on all of the absolute values, this right here could be positive 3 or negative 3. So x is going to be greater than or equal to negative 3. Okay, it's going to be less than or equal to 3 or greater than or equal to negative 3. Right? We got to flip it around because we're going to go this way with 1. Well, once I drop down to the bottom, I have to go back up the other way. So less than 3 and greater than negative 3. Okay, so then when I put that on my number line, right, this is my number line. Okay, so we've got our negative 3 on the left, got our positive 3 on the right. Just like all the other ones, you don't really have to graph every single point. You can just put down the points that you need. Okay, so at negative 3, this is the same thing we've been doing, right? So now it's just like a compound inequality. So x is greater than or equal to negative 3. Okay, solid dot because of the equal to the right, because that's where everything is greater. Okay, and then less than or equal to 3, so solid dot at 3. Okay, less because it's less than, x is less than 3 or greater than negative 3. Okay, all of those would be a distance less than 3, right? So then and is an intersection, right? And is in between. This is my intersection. So that means that x can be anything from negative 3 to 3. Okay, so that would be my interval notation, would go from negative 3 to positive 3. Right? Brackets because of the equal signs. So I've got brackets on both. Negative 3 to 3. Okay? And going back up to this one, you can kind of sort of see that. So negative 3 to 3 on that number line would go from here to here, right? And it would be everything in between. Okay? From negative 3 to 3, everything from here to here would be a distance, okay, that is less than or equal to 3. So a distance less than or equal to 3 from 0. Right? You're always moving from 0. That's what the absolute value means. So from 0, anything in here is less than 3 units away. Anything in here is also less than 3 units away. And that's what that says, between negative 3 and 3. Okay? All right, so then same thing here. Okay, so m minus 6 less than 2, so less than is and. I like to write that down first just because it kind of helps me to keep things in my mind the way I need to, right? So then we set up our two equations because absolute value always has two equations. That's how we get rid of the absolute value to solve, right? Because I'm not allowed to plus 6 out. We talked about the fact that this is a special property, right? So we can't just plus 6 out of there. We have to set up two equations to get rid of that absolute value. So m minus 6 is less than 2. Less than is and. M minus 6 is greater than negative 2. Okay, so we change the inequality and the sign. That's super important that you change the inequality and the sign. Okay, so on the second one, it becomes greater than negative 2. Okay, m minus 6 is less than 2, and m minus 6 is greater than negative 2. Because again, now we're flopping over to the other side of the number line, so we need to change it to go to the right instead of to the left. All right, so then from there, finish solving. M is less than 8 plus 6 plus 6. M is greater than 4, right? This is an and statement, so there's my inequality. M is less than 8 and m is greater than 4. Let's throw that on my number line. Here's my 4. Here's my 8. At 4, it's open and to the right. Okay, at 8, it is open and to the left. Okay. So again, we're looking for the intersection. That's an and statement. So where it crosses each other would be my solution set. So from 4 up to 8. From 4 up to 8. Okay? So on example 3, same sort of thing. I still have a less than as and. Okay, still have a less than as and, but make sure you isolate first. So just like with the absolute value equations, you have to get that absolute value by itself, right? So we're going to minus that 1 first. Absolute value of 5x plus 1, less than or equal to 9. Once I have my absolute value isolated, okay, now I can determine that it's an and statement. You want to wait because it could change, right? So less than is and then I've got my two equations. 5x plus 1 is less than or equal to 9, and 5x plus 1 greater than or equal to negative 9. Okay, so now go ahead and solve each one of these. I might not have left myself enough room on this paper, but we're going to try. So we minus 1, we get 5x less than or equal to 8. Divide by 5. Okay, and I have got, I'm going to write it right next to it, x is less than or equal to 8/5. And, okay, do the same thing over here, minus the 1. So I've got 5x is greater than or equal to negative 10. Okay, divide by 5. X is greater than or equal to negative 2. So there's my inequality. Okay, this right here is my inequality. Let's put that on my number line. So I've got a negative 2 and a positive 8/5. I know negative 2 is smaller because it's negative, right? Negative always smaller than a positive. So at negative 2, it's a closed dot, and to the right, because it says x is greater than negative 2. At the 8/5, it is a closed dot, and to the left, because x is less than or equal to 8/5. Okay, and then it is that intersection, because again, it's an and statement. Okay, so my interval, which is really my solution set, so you need that interval. So don't skip the interval on all these. Notice that's the part that I'm boxing, because that's really my solution set, negative 3 to 3, 4 to 8. Here we're going to go from negative 2 with a bracket up to 8/5. Okay, this is my solution set, right? That's what all my answers can be. Anything from negative 2 to 8/5. Bracket means that those 2 points are included, so you could use negative 2 and 8/5 as well. Okay? So on that next one, right, we get this, 2x minus 1/10 is less than negative 13. Okay, so absolute value, we kind of already talked about this in the equations, right? Absolute value is always positive. Okay, well, if absolute value is always positive, it can't be smaller than anything negative, because smaller than a negative would be more negative numbers. Okay, and the absolute value is always going to be positive. So there's no way for the absolute value to be smaller than a negative number. Okay, if you think about the number line, and I'm just going to kind of draw it here, but if I have negative 13, and this thing says that this is supposed to somehow be less, right, well, that would be numbers out here. Well, that means this whole thing, right, negative 14, negative 15, all of the possible answers would have to be more negative numbers. And I can't have an absolute value that's equal to a negative number. Okay, so that's not going to work. So we'll just make a little note. So this is automatically no solution, right? A positive can't be less than a negative. Right? Absolute value is always positive, and a positive can never be smaller than a negative. That just doesn't work, right? So that's going to be like that. If by chance you were to work this out, kind of keep in mind that once you actually solve this thing, so let's just say, for instance, that you tried to do this. You don't have to write this down, but it's just kind of, because a lot of people will just not remember this, and they kind of keep solving it. So let's just say that I did. So let's say I did my 2 situations. So I did that. Less than would be an and. I would get 2x minus 1/10 is greater than a positive 13. Okay, so I go and I try to solve this thing, which we're not going to like anyways, right, because it's got that fraction in it. Okay, so I get 2x is going to be less than negative 12 and 9/10. We're just going to take away 1/10 out of that, right? And then you would, well, here, let's not do it that way. So that would be 130, so that would be negative 129 over 10 when you get a common denominator. That might be a little easier, believe it or not, it will be. Okay, so then plus 1/10 plus 1/10, so 130 plus 1, so 2x is greater. I'm kind of working both at the same time. 131 over 10. So then you would divide by 2, which is the same thing as multiplying by a half. Okay, so you get some really ugly x is less than negative 129 over 20, and x is greater than 131 over 20. Okay, so what happens here, and I know these are super ugly numbers, don't really worry about that. So what really happens here, and this is kind of the part I want you to see. So I got negative 129 over 20, which we know is over here because it's negative. X is less than, so that's open and to the left. Okay, and then on the other side here, we've got 131 over 20, and that's open and to the right. Okay, and this is an and statement. I know I got all kinds of stuff going on. Okay, point being is that if I actually did this and I did my and statement, and I solve for x, okay, what you're going to see is an and statement that doesn't cross. Okay, so I've got an and statement with no intersection. Okay, and an and statement that doesn't cross has to be no solution, because, you know, if they have nothing in common, then there's no intersection. So you just have no solution there. So If by chance you were to find one that is less than a negative and you forget to write down automatically no solution, you could keep solving it. You're going to get the same answer because once you get here, your graphs are going to go opposite ways, and anytime you have an and that doesn't intersect, it's still going to be no solution. So it still works out even if you solve it out. That's real ugly because it's got nasty little decimals and fractions, or nasty little fractions in it, okay? But that's exactly what's going to happen. All right. So now those are all the and statements. Let's look at an or statement, right? More than is or, so that's a greater than. So this is automatically an or because absolute value is already isolated. So then we set up our two equations just like we did before. Y minus 3 is greater than 7, or y minus 3 is less than negative 7. Okay, so I'm still going to flip the sign and the inequality, right? So the inequality flips over, the sign changes to a negative, okay? And I'm still going to solve it the same way, plus 3, y is greater than 10, plus 3, y is less than negative 4, okay? Difference being that this is an or statement, so now we don't need an intersection anymore, okay? So with the or statement, I've got negative 4, open circle because there's not equal, to the left because it's less. I've got positive 10, open circle to the right, okay? And or statements is anything covered by either one of the sets, right? So basically everything covered by a line, and we kind of talked about this when we did compound inequalities. Okay, it's an or statement, right? And they have two different parts. So this is the one where you use the union. So we write the interval for the first part, which will go from negative infinity all the way up to negative 4, right? And then parenthesis because it's not equal. And then we use the union to show the gap, right? Because it's this piece unioned with this piece, so we use that union to kind of show that there's a gap here. And then we pick back up at 10 and head off out into positive infinity, right? So just going left to right, negative infinity up to negative 4, stop, unioned with, okay, because we don't want to include any of this because this is not being covered by anything. And we pick back up at 10 and go out to positive infinity. Okay, so same thing on example 6. Isolate first, so we're going to minus the 5 over. So we've got the absolute value of 2x plus 9 is greater than negative 2. Okay, absolute value of 2x plus 9 is greater than a negative 2. So anytime this negative shows up with your absolute value, that should ring bells. Okay, big giant red flags should hop up in your face and sirens going off, I don't know, something. Okay, but anytime you see a negative answer with a absolute value, okay, and I'm not talking about a negative answer, okay, we can have answers that are negative, there's nothing wrong with that, but the absolute value can't have a negative on this side. Okay, so here, this says that the absolute value of whatever this is bigger than negative 2. Well, same thing. Absolute value has to be positive. A positive number is always bigger than a negative number. Always. Okay? So always bigger. So in interval notation, this one's going to be negative infinity to positive infinity, or all real numbers. Okay? If it doesn't ask for interval notation, all real numbers would work. Because here, anything that I plug in here, once I take the absolute value, it becomes positive, will always be bigger than a negative. Okay? And you can write that down. A positive will always be bigger than a negative. Okay? It doesn't matter which side, okay? It doesn't matter what size the positive number is or the negative number is. Every positive number is bigger than a negative number. Okay? So, again, let's say that you just didn't catch that and you didn't see that. Well, that's fine. Just keep going, right? So I would go, this is an or statement. And I've got 2x plus 9. I'm going to work at the bottom here so I have more room. 2x plus 9 is greater than negative 2, or 2x plus 9 is less than positive 2. Okay, I solve these things. Minus 9. 2x is bigger than negative 11. Divide by 2. I know I'm going kind of quick, but you can always rewatch this if you need to, or pause it so you can write it down. Right, so x is greater than negative 11 halves, or, okay, minus 9, 2x less than negative 7, divide by 2, x is less than negative 7 halves. Okay, so it's bigger than negative 11 halves, or it is smaller than negative 7 halves. Okay, negative 11/2 is bigger. It's open. It's to the right. Okay, negative 7/2, right? Bigger negative, right? Means that it's actually a smaller value, so bigger negative, smaller value. Plug that into your calculator if you don't know how to line these fractions up. Okay, you should, because, right, 11/2 versus 7/2. Bigger the negative, the less smaller the value. Anyways, but if not, use your calculator, look at the decimal. Okay, so then x is less than negative 7/2, so it's open and to the left. Okay, well here again I have an or statement, right? Because this was an or. Well, in an or statement, it's anything covered by one, the other, or both. Well, that's everything. Okay, this one covers everything that way. This one covers everything that way. They both cover that area in between. Okay, so here it's going to be all real numbers either way, negative infinity to positive infinity. Okay, so regardless of whether you recognize that, although it should, again, if you have absolute value and there's a negative number on this side, that should just raise red flags. Okay, you're going to end up with either that no solution or that all real numbers, and it just depends. Less than a negative is no solution. Okay, a positive will never be less than a negative. A positive will always be greater than a negative no matter what you do. Okay, so then that very last one, it's got that 0, which just throws people off just a little bit, so let's talk about it. Okay, so here, less than or equal to 0, okay, you would do the same thing, right? Okay, but we already talked about the fact that it can't be less than 0. Less than 0 is negative numbers. Absolute values can't be smaller than negative numbers. So this can't be smaller, okay? Cannot be less. Okay? Positive cannot be less than a negative, or less than 0, right? Because less than 0 are negative numbers, so it cannot be less. Okay? So that means the only thing it can be is equal, because a positive can equal, right? Because the absolute value of 0 is 0. Okay, so 0 can equal 0. So that's the only thing it can be is 0. So that's the only one we have to worry about, is when it equals 0. Okay, because the absolute value of 0 is 0. So you can get a 0. Okay, so then you would solve, right, times 3 gives me 2. Most of you guys will probably distribute, but you could just divide the 2 over, take your pick. Okay, but most of you guys will distribute, so I'll go ahead and do that for you. 2x plus 2 is equal to 0. Minus the 2 over, 2x is equal to negative 2 divided by 2, x is equal to negative 1. Okay, so x is equal to negative 1 is the one and only solution to this absolute value inequality. When you put that on a number line, okay, it is for real a dot. Okay? There is no line. It doesn't go left. It doesn't go right. It's for real just negative 1. So you just have one nice pretty little dot at negative 1. That is your only solution. Okay, so that's it for absolute value inequalities. Okay, if you're struggling with some of this stuff, go back and look at compound inequalities. That'll kind of help with the inequality part and writing the interval notation. Okay, I went a little slower on writing the interval notation in that 9.1 part where we looked at those compound inequalities. So if you're struggling with that, look at that. If you're struggling with the setting up the two equations, okay, go back and watch the absolute value equation section, which was the 9.2, right? So you can watch those, and that'll kind of help you with why we get them set up that way. This one is just combining those two skills. Okay, good luck with that.